Okay, so here's problem set 1. Hopefully everybody was able to give these a try. I'm going to go through these examples one by one, showing you how to work these problems out. So these are called two-step equations. The reason why they're two-step equations is because there's 2 steps required to solve each one. And by solving each one, what we're doing is trying to figure out what that variable is equal to. So what value for the variable f makes this statement true? So you might be able to do some guess and check type of math to try to figure this out, but once it gets a lot more difficult, you're not going to be able to use guess and check. So from here, from two-step equations, you go to multi-step equations. And you could eventually see in Algebra 1 an equation that involves up to maybe 6 steps or more in order to solve it. So we have to come up with this method here and get used to using it. So as you saw in the presentation, the first step is always going to be adding or subtracting. And the second step to unwrap the variable is to use multiplication or division as your inverse operation. So I always start by boxing off. I like to box this off and draw my line straight down just to keep organized. So here's my variable. I want to unwrap it. I want to get this all the way down here so that I've isolated the variable and it stands alone. So in the end, I want it to say f equals and then a single number. So we're going to start by reading this. And when I read this, it says 7 times f plus 5. So the 5 is the last thing I said. The 5 is applied to the variable after the 7. So the 7's applied to it, and then you're adding 5. So let's start by working our way. We start further from the variable and work our way towards it. All along, this 40 is always going to stay over here on the right. So let's start by subtracting 5 from both sides. Annie Greenwich, Mrs. Dulac, the department head, has said this for many, many years. She wants us to show our thinking in one straight horizontal line like this. She doesn't want you putting the -5 below because it becomes problematic once you get to Algebra 2 if you're doing your solving that way. For now, I'm just saying whatever makes sense to you is the way you work these problems out. If it makes more sense for this one, add 6 to both sides like this instead of doing it in one straight line, that's completely fine. I actually learned solving equations this way. It kind of made sense to me because I could clearly see a -6 and plus a +6 cancels out to make 0, so there'd be nothing here, and then I'd just be left with 12t over here. So if you want to do this vertically, by all means, go for it. As long as you're learning, that's all I care about today. So we're learning something new. So these cancel out to make 0. And in the next line, I'm going to simplify this left side. I have 7f equals, and then 40 minus 5. Let's simplify the right side, 35. Okay, so I'm going to erase this so I have a little more room. Now you can see that it says 7 times f. So in order to get f alone, we want f alone, isolate that variable, we have to use division. If I divide both sides by 7, whatever you do to one side, you have to do to the other to keep this balanced and maintain equality on both sides. When I divide 7 by 7, what I get is 1. So this is just 1f. So I have 1f on the left, and then 35 divided by 7 is 5. So far, so good? All right, so the next one, sorry, 1 second. Okay, the next one, we did the first step already. So I'm going to draw my line down and stay organized. 96 when I simplify the right side. And on the left side, all I have left is 12t. So I'm going to funnel that down. So this says 12 times t. I'm going to end up needing to divide both sides by 12. I like to use the fraction bar so I can clearly see 12 divided by 12 is 1. Now my coefficient is 1. 1 times t is just t. And then 96 divided by 12 is 8. Okay. Add 7 to both sides. So I could go like this, plus 7, minus 7. So my plus 7 is now, I've incorporated that into both sides. So a plus 7 and a minus 7 makes 0. 5q equals 20. Going to see that this is multiplication again. So all 4 of these examples involved multiplication. So we're using division. Okay, that's not always going to be the case, and you'll see that in problem set 2. So these cancel out to make 1. So q equals 4. And you can always double check. So if you're not sure if you get it right, you're going to substitute that value 4 back into this equation. So the check would look like this. 5, does 5 times 4 minus 7 equal 13? Does 20 minus 7 equal 13? Yes, 13 equals 13. So that is correct. That's what I love about this. You know if you're right or wrong before you even submit your problems, just by checking by evaluating them. So you just plug this back in for t and you can check. 12 times 8 minus 6. Does that give you 90? All right, here we have addition and multiplication. So first step is always add or subtract. So I'm going to subtract the 8 from both sides. And don't forget this is a negative 12, so be careful there. All right, so these make 0. So on the left, I've got 4y equals, now be careful, I have a negative minus a positive. So subtracting a positive is the same as adding a negative. I'm taking away from a negative, so I'm going to have more negative. So this actually becomes, if you do side work, remember we called it the keep, change, change rule. Subtracting a positive is the same as adding a negative. So this comes out to negative 20. Undo the 4 by division, so that clears to make 1. And negative divided by a positive is a negative. So that's problem set 1. All right, now you can see problem set 2 involves addition, subtraction, multiplication, but we have this new operation involved, division. So this fraction bar here is showing me, it says 6 equals a divided by 4 plus 2. So I'm going to start the same way I did in problem set 1. I'm going to think of what is the inverse operation of addition. It's subtraction. So I'm going to subtract 2 from both sides. Okay, so now this makes 0. Okay, and the other different thing that's different here is that now my variable's not on the left anymore, it's on the right. And that's fine, you can just leave it over there. So we've got a divided by 4, and then over here we have 4. All right, so now multiply both sides by 4. Why am I multiplying both sides by 4? Well, the inverse operation of division, here's my division bar, is multiplication. So these two are going to clear. These are going to cancel out. And remember back when we learned how to multiply a whole number times a fraction, we would make this improper, and then we could simplify before we multiply. So if we simplify these factors, these clear to make 1s. So as you can see now, on my right side, by multiplying using the inverse operation of division is multiplication. So to undo this divide by 4, I'm multiplying by 4 on both sides. I'm going to clear this all out to make 1a. So 1 times a is 1a, so it'd look like this, over 1 times 1. Okay, which is just a. So I just write a. So there we have it. We've isolated the variable. And on the left, we have 16. Just leave it like that. Leave it. You don't have to have the variable on the left. You can let your answer look like that. All right, the next one, we're adding, this is a little tricky now, we're adding, but we're not going to use subtraction to undo the -6. And this is a common error. Students will look to this sign and use subtraction here as their first step. But what you really want to do is actually use addition, because adding a negative is the same as subtracting a positive. I could rewrite this whole thing to look like this. Remember, this positive sign is going to go with the x. Okay, so it's saying the x is positive, not the 6. So I could rewrite this like this. Okay, so these two expressions on the left are equivalent. So let's use this one. Adding 6 to both sides. Let's cancel to make 0. Next, I want to cancel this 4 to make it 1x. And then here I have a positive 1. So a negative and a positive, we're subtracting those. When you're adding with different signs, find the difference. So we're subtracting those. We're going to multiply both sides by 4. Okay, so this is over 1. So you're going to clear those out. These make 1s. And I'm left with x equals 4. I think we should check this one because that was a lot. Let's just double check our work. So go back into the original equation. Here's our check. So -6 plus, we said x was 4, 4 over 4, equals -5. So does -6, I substitute the 4 in for x. And then 4 divided by 4 is just 1. So the -6 plus 1, yep, that's -5. You're going to find the difference there and take the sign of the larger absolute value. So subtract them, take the sign of the larger absolute value. You're good. Okay, so all those integer rules we've been working on all year are coming back into play. All right, so last two, very straightforward. I've got -7. So my brain tells me I'm going to add 7 to both sides. Okay, look what happens here. I've got -7 plus 7. That makes 0. So on the left, I have 9x. On the right, I have 0. Let's just keep going. Okay, don't let that fool you. So we have multiplication here. We're using division to undo the multiplication. We're unwrapping that x to get it alone. And 9 divided by 9 is 1. So that's just 1x there. And 0 divided by 9 is 0. So this is quite possible. You could have a solution equal to 0. And if you plug that back in, does 9 times 0 minus 7 equal -7? Does 0 minus 7 equal -7? Yes, it does. -7 equals -7. So we're good. All right, last example here in problem set 2, and then you're ready to roll. So we're going to look here. Here's our variable. I'm going to first undo the 4, then the 5, okay? Remember, I'm starting away from the variable and working my way towards it. So the first step is always addition or subtraction. So I need to subtract the 4 from both sides. Now be careful. You're not subtracting 0 from 4. You're subtracting 4 from 0. So with subtraction, order matters. So make sure you're subtracting the 4 from the 0. And this is when I think it actually seems to make more sense to not do it in one horizontal line. I think intuitively as 7th graders, this might make more sense to you. So if we do this vertically, 4 minus 4 is 0, right? 0 minus 4 is -4. And then I can simplify my right side. And then I have one last step. So now we have a one-step equation. And in order to solve this one-step equation, I'm going to need to multiply both sides by 5 to undo this division of 5. the inverse there. I'm going to have to move this over here. Okay, so I'm going to multiply this side by 5 as well. Okay, so these two cancel. On the left, I have negative 20, and on the right, I have n. Okay, let's check it. So does 0 equal 4 plus negative 20 divided by 5? Let's see. So 4 plus, what's negative 20 divided by 5? It's negative 4. So does 4 plus negative 4, I can put those parentheses in there to separate those two signs. Does 4 plus negative 4 equal 0? When you add two opposites together, you get 0. All right, and that's all I had for you today. Thanks for watching.